Okay, this is just a little basic video I'm making with my iPhone as my molecular kit on my living room floor. You may have some input from cats, they're very fascinated by what I'm up to, but I just wanted to try and talk through geometric isomers with you. Okay, so here is a little molecule on my floor, and as you can see we have two black balls, and each black ball is a carbon atom. The white balls are hydrogen atoms, and the green balls are functional groups, and they can be any kind of functional groups. It could be chlorine atoms, bromine atoms, or carboxylic acid groups. Doesn't matter, they're just functional groups. Now there's a single bond connecting these two carbons, and as you can see, this mimics what happens in real life. The two carbon atoms can rotate around this bond in relation to each other. So here we have the molecule looking like this, and it can look like this, and it can look like this, or it can rotate here, and it can end up looking like that. So if I then bring another molecule in which looks exactly the same as that, okay, you would say, well, they're not isomers of each other because they're the same molecule. Okay, but what if I do this? Are they still the same molecule? Well, yes, they are. Even though it looks like they're in different places, they're not, because very quickly the atoms are rotating in relation to each other all the time. So very quickly it can rearrange itself to be in the same configuration as that one. The two are superimposable on each other, so therefore they're not isomers, and they're certainly not geometric isomers. So I hope that makes that clear. Let's put them just to the side here. Now here we have another molecule, two carbon atoms, black balls, hydrogen functional groups, joined by a double bond. Now this is where it gets really interesting. This is where working with a molecular kit is really interesting and fun. When I try and twist that carbon atom in relationship to that one, it will not move. It's stuck. It is stuck, and it's stuck in real life as well. So if a carbon is bonded to another carbon with double bonds, it's a very rigid bond. And we have two functional groups on this side, two hydrogen atoms on that side. So there's no way though of rotating that over to the other side. It's stuck there. Okay, so if I bring in the other version, yeah, functional groups from different sides of double bond, they can't rotate. That can't rotate to the other side because it's rigid. These two are not superimposable on each other. They are not. You can see that. They're different. So these are geometric isomers. Okay, so this is the cis version. The functional groups, apologies for the cat intervention, functional groups are on both sides of the double bond, and the trans version where the functional groups are on different sides of this double bond. Okay, so I hope that helps, and I do recommend you working either with a kit if you can, or just getting some cocktail sticks and grapes, or even bits of blue tack, and trying this out for yourself. It really does help.